Okay, hi there. This is Dr. Matthew J. Trom from Engineer Inc. The point of this video is to share how a rotary viscometer works. The reason for this is that we are giving you viscosity versus time curves for your Ford 4 viscosity cups, which came in your kit. And I'd like to show you where those curves come from, like how we calculate them. So the way that this works, it's called a rotary viscometer. This one happens to be an NDJ-8S viscometer. And the way that it operates is you can see down here there's a series of different spindles or rotors is what they're called. And let me just pick one up. So you can see there, it's just like a straight rod, and then it has kind of a disc on the bottom. And this one happens to be, see if we can see there, the number 3. Not sure if we can see that, but there we go, number 3. And different numbers correspond to different disc shapes. So this one is number 2. This one is going to be number 1, and you can see that this one has quite a bit larger area than the other ones. And then, of course, number 4 is down here, which is literally just a straight rod with no kind of disc surface associated with it. And ultimately what we'll do is screw those in to a little attachment here and tell the viscometer which number rotor that we're using. And the viscometer is calibrated, so it has like a torsional spring on the inside, and it will, knowing the rotor geometry, because we plugged that in, it knows how much, based on the deformation of that torsion spring, how much torque is being induced by the rotor spinning in some sort of liquid. So I'm going to take a graduated cylinder, a beaker like this one, and I'm going to put the fluid of interest in it. So we're going to use binary mixtures of tap water and corn syrup, and we're going to increase the mass fraction of corn syrup from basically 0 up to 100 and give you guys the curve for all of those viscosities and the drain time from the Ford 4 viscosity cup. But that binary combination of tap water and corn syrup is going to cause these spindles to put some sort of back torsion or back torque on that torsion spring. And as a result, the viscometer is going to tell us what the force is. So you can see here, what the torque is, and convert that torque into the viscosity for the fluid. And so you can see here, I have the ability to change the rotor number, so I can go 1, 2, 3, 4, and so forth. And then I can go down here, and I can also change the rate of rotation. Now, you may have learned in fluids about Newtonian versus non-Newtonian fluid, shear thickening, shear thinning fluid. If you have a non-Newtonian fluid, particularly shear thinning or shear thickening fluid, it's a fluid that changes its viscosity depending on how quickly you shear it. So it turns out the good news with water and corn syrup is both of them are Newtonian fluids and their viscosities are constant. So it shouldn't matter how fast I rotate this thing. The viscosity is constant no matter what the rate of rotation. So I'll set, an appropriate rotor rate to get a good torque measurement. And then I'll just let it spin for a little while. And when it reaches steady state, when there's no more kind of wobble in the torque, I'll pull the viscosity data off of the viscometer. I'll record that. And then that becomes the value on the y-axis of the chart that I give you guys. The x-axis of the chart, as I mentioned, you guys have got your Ford 4 cups, right? You guys have got these in your kits. So to get the y data for that point on the chart, I'll take that same fluid, right, that has some mass fraction of water and some mass fraction of corn syrup, and I'll run it through the viscometer, the cup viscometer here, and determine the drain time. And when I get the drain time and I know the viscosity of that particular fluid, that's a point on the plot. And if I get enough of those, I'm probably going to end up plotting about 15 or 20 of those points for you guys. That's the curve, the viscosity versus Ford 4 cup drain time curve that you guys will use to determine the viscosities of your particular fluids for the Stokes flow, external flow, falling ball viscometer experiment. So anyway, just wanted to kind of give you an introduction to this. I'll make another video to show you how it actually operates, but wanted to just give you this overview. So thanks for your attention, and I'll see you in the next video.